to my YouTube channel. Today we are going to explore Bayes' rule and we are going to learn the intuition behind it and not the formulas. Let's start with an experiment. Imagine that I blindfold you and hand you a ball and ask you, which box did it come from? Box A or box B? We have no reason to choose either. Let me give you a bit more information. What if I tell you that 70% of the time I choose box A and only 30% of the time I choose box B? Now what would you say? Maybe box A, just because it was more likely to be picked. And this is what we call as prior probability, something that we know before we have any evidence of anything. It is maybe box A, but we don't know for sure. Now what if I give you more hints? I allow you to look at the ball and you see that it's blue in color. I give you a bit more information about the boxes. In box A, 10% of the balls are blue, and in box B, 75% of the balls are blue in color. Now what would you say? Just because we know that the ball is blue in color, we might think that it is more likely to be picked from box B, just because it has more number of blue balls. Now if you see, initially we were inclined towards box A, but now maybe it makes sense that we think that it came from box B. Bayes' rule is essentially this tug of war. There is some prior belief that we had which pulls us towards one end of the possibility, and then after we saw the evidence, we were pulled on the other side. Now, Bayes' rule is just a way of quantifying this intuition. Let us try and put numbers to this intuition. Let's just accept the formula on the screen as it is. What are we trying to calculate is the probability of the blue ball being picked from box B. And we already know that it's blue in color. So given that it's blue in color, the formula is that we multiply the probabilities of a blue ball being picked, given that we are picking from box B, into the probability of box B being picked. Like we decide that we're going to pick from box B. And we scale or normalize this multiplication simply by the probability of any ball, irrespective of what box it's picked from, being blue. Now we know the values for probability of a ball being blue given that it's picked from box B, because we knew that 75% of the balls in box B were blue in color. So the value of this probability is 0.75. We also knew the probability of box B being picked. Initially, I mentioned that only 30% of the time I choose box B, which makes the probability to 0.3. How do we calculate the probability of any ball being blue irrespective of the box it's being picked from? So here there are two possible scenarios. We pick from box A and the ball is blue, or we pick from box B and the ball is blue. And this equation just summarizes these two situations. So probability of a ball being blue given that it's picked from box A into probability of box A, and similar for box B. All of these values are known to us, so it's just plugging in the values and getting an answer. So probability of any ball being blue irrespective of the box it's picked from is 0.295. And then when we plug in all these values in the final formula, the final value that we're looking for is the probability of the ball being picked from box B is 76%. Now, if you recall, initially when we only knew the times the box were going to be picked, that is 70% of the time I choose box A and 30% of the time I choose box B, we were heavily inclined towards the ball being from box A. But after the evidence showed up, the odds flipped. And this is exactly what Bayes' rules helps us. It helps us update our probabilities after we have seen some evidence. So in general, Bayes' rules looks like this. Probability of an event A happening, given that event B has already happened, is equal to the multiplication of probability of B happening given A has already happened times probability of event A. And we scale this divided by the probability of event B happening. Now the nature of this formula is such that we can call these terms individually and they have certain terms, and it is because they have some meaning to it. So in Bayes' rule, we start with a prior, probability of event A. It was probability of a box being picked before we even knew that the ball was blue in color. So this probability is called as prior. It is a belief that we had before we saw the evidence. And then using Bayes' rule, we are trying to update this prior to calculate a posterior probability, which is an updated belief after we have seen the evidence. So probability of event A, given that we have already seen the evidence B. So this is called the posterior probability. What was the evidence B? So probability of an event B happening in itself is the evidence. So any ball being blue is the evidence that we are trying to account for. And likelihood is simply the compatibility of the evidence with the event. So how compatible is the evidence with the event A that we are trying to gauge is simply likelihood. So these are the terms, this is how we use Bayes' rule to update our beliefs using the evidences we see. I hope you guys got an intuition of what Bayes' rule is and how we use it. It's the most fundamental rule in mathematics, in science, in probability. It shows up in every aspect of life, right from medical diagnosis, self-driving cars, and even our autocorrects. I will link down a few more stuff for you guys to go through, learn from, but always remember it's about having an intuition of the concept, not memorizing it, because the intuition will help us formulate problems, which is the hardest part of solving them. Thank you so much for watching, and I will see you in the next video.